Hey everyone, in this video we're going to learn about scatter plots and the line of best fit. Make sure to have your graphing calculator nearby. Starting off with a few definitions, a scatter plot is a graph of plotted points that show the relationship between two sets of data. In the scatter plot to the right, each data point represents hours spent studying versus how many questions they got correct on a quiz. So here is our first example of a scatter plot. Notice the horizontal axis is the number of hours studied, and the vertical is the number of correct answers. So each data point represents an individual. So for instance, this data point here represents a person that studied for 4 hours and got 7 correct answers. The data point right here, a person that studied for 1 hour and got 3 correct answers. And we can see there are many more data points in this scatter plot. Now the line of best fit, also known as the trend line, is a line we can draw on a scatter plot to show the relationship between the two sets of data. We can use the line of best fit to make predictions based on the data. So we don't want to play connect the dots to create our line of best fit. We want to draw a straight line that gives a good estimation of the data points. Okay, so if I use the line tool, so for instance, this would not be a very good estimation of the line of best fit. All the data points are clearly above that line. Similarly, this wouldn't be a very good estimation of the line of best fit. All the data points are now below. Here, it's a little bit better. Okay, but if we keep moving, let's say something like that, that would be a very good prediction of what the line of best fit should be. We have a few points above the line, a few points below the line, and in general, it looks like that line is going in the same direction, the same trend as the data points. Okay, so we'll put an arrow at the end of it. And we can use this to make predictions. So if we extended this line out and we wanted to know how many correct answers you would get if you studied for 7 or 8 or 9 hours, we'd be able to make that prediction based off the line of best fit. Okay, so now that we know what a scatter plot is, and how we can use that to estimate a line of best fit, let's create our own. The table below represents the number of squats Matt completed based on the weight in pounds of the dumbbell he held. Okay, so we have weight going across, so 0, 10, 20, 30, 40, 50, and 60. And then the number of squats we can see follows. Okay, so we want to create our scatter plot first, so we're going to want to scale our axes to fit all of our data points. So we're going to have weight on the horizontal axis and the number of squats on the vertical. Okay, so for weight, we need to get up to 60, and there's 10 boxes. So going by 10 will be the best choice here. 30, 40, 50, 60, 70, 80, I'll stop there. And squats, we have to get up to 20, and again there's 10 boxes, so we'll go by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so now that we've scaled our axes, we can plot our data. So 0, 20 is our first data point. Then we have 10, 18, 20, 16, 30, 10, 46, 52, 62. Okay, so that completes the first part. We've created a scatter plot of the data. Now we want to draw in a line of best fit. Okay, so going to start there because they should have about the same y-intercept. And again, that would be okay, but those points that are below it are pretty far off. That would be okay, but there's points on it, points above it, but no points below the line. So trying to hit right in the middle, something like that, would be a very good estimation of the line of best fit. Okay, and doesn't have to look exactly like the line that I drew, but it should be about in the same vicinity. Okay, so now the question is, can we create an equation for the line of best fit so that we're not just estimating it and we actually have an equation based off the data that we've collected or been given? And the answer is yes. We're going to use our graphing calculator to do that. So to find the most accurate equation for the line of best fit, we will use a linear regression. And the steps for finding a linear regression on the graphing calculator are listed here. Now, instead of reading it line by line, let's actually go through this with our previous example, and you can follow along with your graphing calculator. And then you can always reference these steps if you need to in the future. Okay, so I'll pull up the graphing calculator. Okay, so we have weight and we have squats. So we're going to hit Stat, Edit. Okay, my lists are clear. If yours are not, scroll up to L1, hit Clear and Enter. That should clear all the entries. So we'll start by typing in the weights. So 0, 10, 20, 30, 40, 50, 60. And then we'll go with the number of squats. So 20, 18, 16, 10, 6, 2, 2. Okay, first thing you always want to check is make sure you have the same number of entries in L1 and L2. If you don't, you're going to get an error when we continue on. And then just give it a quick once over to make sure everything looks like you typed it in correctly. Now we're going to hit Stat again. We're going to move 1 to the right to Calc. Now we've seen the screen before because we've used one variable statistics, but in this case we're going to scroll down to choice 4, which is a linear regression in the form ax plus b. We're going to hit Enter. Now if your screen looks like this, you want to make sure there's an L1 here and an L2 there. If not, to put L1 you hit second 1, you see the blue L1 above, and then for the Y list you can do the same thing but hit second 2. If your screen doesn't look like this and you just see linreg, you should be good to just hit Enter. Now I'm going to scroll down to highlight Calculate, and once I've done so I'm going to hit Enter, and now we should see this screen. Okay, so I'm going to pull the screen into our notes. Okay, so the nice thing about running a regression on the calculator is they give us the format of the equation. Right, you can see that right there in that first line, y equals ax plus b, which is the slope-intercept form of a line. And then they tell us what a and b are, to quite a few decimal places. And if we read the question, state to the nearest tenth the linear regression equation that approximates the number of squats Matt completed based on holding a dumbbell with a weight of X pounds. Okay, so we're going to take the values that they've given us and round to the nearest tenth. So our linear regression equation is going to be y equals negative 0.3x plus 20.9. Right, and the idea here is the more decimal places that we keep, the more accurate our prediction would be. Now, once we have that linear regression equation, we're usually asked follow-up questions. So based on the linear regression equation, how many squats can Matt do if he uses a 25-pound dumbbell? Round to the nearest whole number. Remember, the way we define this is x is the weight of the dumbbell and y is the number of squats. Okay, so if we're trying to figure out how many squats he can do based off using a 25-pound dumbbell, well, this is going to be our x value. So we can plug that in. So negative 0.3 times 25 plus 20.9. And since we have our calculator, let's use it. So negative 0.3 times 25 plus 20.9. Hit Enter. 13.4. Let's fix the 4, so 13.4, and it says round to the nearest whole number. So rounding that, we would have 13 squats. Okay, so based on our linear regression equation, it predicts that if he uses a 25-pound dumbbell, he'd be able to do 13 squats. Now use the linear regression equation to estimate the weight Matt used if he did 7 squats, round to the nearest pound. Okay, so now they're telling us the number of squats, they want us to work backwards and figure out what weight he used. So 7 then is going to be our y value. So we'd have 7 equals negative 0.3x plus 20.9. We can start by subtracting 20.9 from both sides. So You can do it in the calculator just for practice here. 7 minus 20.9. So that's negative 13.9 equals negative 0.3x. Divide both sides by negative 0.3. So since we use our calculator, we could just hit divide by negative 0.3. When it says answer, it's going to use that negative 13.9 there. Enter, so 46.3 repeating equals x. So we're rounding to the nearest pound. So 46 pounds. And again, based on the linear regression equation, if he completed 7 squats, the equation predicts that he used a weight of 46 pounds. Explain what the slope means in the context of this problem. Okay, so our slope is negative 0.3. Remember, x was weight, y was the number of squats. Slope is change in y over change in x. Right? We've used that throughout this course. So that's helpful in explaining what it means in the context of this problem. Right? The change in y over the change in x. So the slope being negative 0.3 means the number of squats Matt completes decreases by 0.3. Don't include negative because we already said decreases, as the weight increases by 1. Right? Because if you think about it, it would be negative 0.3 over 1. Right? Change in y, change in x. So we describe the change in y as the change in the number of squats, and then the change in x is the weight of the dumbbell. So as the weight increases by 1, and we should say pound here just to be more specific. Now, that's a little weird to think of. Okay, so if you want to think of it in a different way, we can express 0.3 as 3/10. So we could technically write that same slope as negative 3 over 10. And then our description would be the number of squats Matt completes decreases by 3, right? Change in y is the numerator, as the weight increases by 10 pounds. That's the denominator. And that would be another acceptable explanation of what the slope means in the context of this problem. That might make more sense to you because we're using whole numbers as opposed to this decimal, right? For some people, how does the number of squats decrease by 0.3? That's a little weird. But in this version, the number of squats decreases by 3 as the weight increases by 10 pounds. Okay, so you can write that out as well. The table below represents the number of questions students answered correctly on a 20-question multiple choice test based on the number of hours they studied. Okay, so we have hours spent studying and the number of correct answers. So again, we want to scale our axes so that we can fit all the data points. Okay, so horizontal axes we'll label as hours studying, and the vertical is the number of correct answers. Okay, so on the horizontal axes, we have to get up to 8, and they've given us 20 boxes. So just to spread it out a little bit, every 2 boxes will make 1. 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then on the vertical axes, the largest number is 19, so we'll just go by ones. And I'll only label every other box. So 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, now that we have everything scaled, we can plot our data points. So 417, and then 514, and then we have 310, 15, 818, off one there. Got to move it one to the right. 818. And 311. So that's right above a data point that was already there. And 619. Okay, so there's our scatter plot. Now we want to draw in our line of best fit. Okay, so again, we want to estimate the data points as best we can. Okay, so something like this line right here would be a pretty good estimation. Maybe off a little bit, but again, we're just estimating what the line of best fit looks like. If we want the accurate equation, we can use our calculator. So that'll be next. State the linear regression equation that approximates the number of questions answered correctly based on the number of hours spent studying. Round your answers to the nearest hundredth. Okay, so back to the calculator. Stat, edit. First thing we want to do is clear our lists. So up to L2, make sure it's highlighted, clear, and enter. And same thing for L1, clear, enter. Okay, so for hours spent studying, we have 4, 5, 3, 1, 8, 3, 6. And number of correct answers, so we have 17, 14, 10, 5, 18, 11, 19. Hey, so make sure everything matches. Always important that it also matches the data point, right? So 417 should be paired together. 514, right? We can't just enter them in an arbitrary order. So everything looks good here. So we're going to hit the stat key again, scroll over to calc, down to choice 4, hit enter, scroll down so that we have calculate highlighted, hit enter, and there we have our screen. Okay, so again, they give us that format, y equals ax plus b, that slope-intercept form, and they give us a and b. We're rounding to the nearest hundredth here. So we have y equals 1.95x plus 5.09. So now use the linear regression equation to determine how much lower the actual number of questions answered correctly was compared to the predicted number after 1 hour of studying. Okay, so first we have to find that predicted number, right? The number of hours, that's x, correct answers is y. So the prediction, so y equals 1.95 times 1 plus 5.09, not 6, that should be a 9, 5.09. Okay, so we'd have 7.04. Okay, so this is the predicted. Now the actual is from the data point, right? So that's right there. The student who studied for 1 hour got 5 answers correct. Okay, so now we want to find the difference. We want to say how much lower the actual number of questions answered correctly was compared to the predicted. So we want to find the difference. So predicted is larger, so we'll do 7.04 minus 5, and that's going to be 2.04. Okay, so based on our linear regression equation, the actual data point was 2.04 lower than what the actual was. Than what the predicted was, rather. Okay? So, predicted we got from the linear regression equation, actual from the data point, and we found the difference between the two. Based on the linear regression equation, how many hours would a student need to study to answer all 20 questions correctly? Round your answer to the nearest integer. Okay, so number of questions answered correctly, that's our y. So we're going to plug 20 in for y, equals 1.95x plus 5.09. We'll start by subtracting 5.09 from both sides. So that's going to be 14.91 equals 1.95x. We can divide both sides by 1.95. And we'll use our calculator here. So 14.91 divided by 1.95. So we have 7.646. 7.646 equals x. So we're rounding to the nearest integer. So that would be 8 hours. So our equation predicts that if you studied for 8 hours, you would get all 20 questions correct. Now, that might not actually be the case. We can see here, there was a student who studied for 8 hours and only got 18 questions correct. But this is a prediction based off the equation. What does the y-intercept mean in the context of this problem? So y-intercept is the constant in our linear regression equation, so 5.09. Right, so that would be 0, 5.09 if we wrote it out as a point. Okay, so remember, x is the number of hours studied, and y is the number of correct questions. So what this is saying is if you study for 0 hours, the equation predicts that you'll get 5.09 questions correct. Now, a little difficult to get 0.09 of a question correct, but remember, this is a prediction. Okay, so if you study for 0 hours, the equation predicts you will get 5.09 questions correct. Perfect. One last example to practice with the calculator. Write a linear regression equation for the following scatter plot. Round all values to the nearest integer. So they've given us a scatter plot that shows the number of newspapers delivered based on miles driven. Normally we create the scatter plot based off of a table they've given us. We're just going to work in the other direction. So we can create a table based off this scatter plot and then use the calculator to write our linear regression equation. So we have miles and we have the number of newspapers delivered. Okay, so first data point is 120, and then we have 230, 360, 460, 570, 690, 700, 830, 930, and 10150. So pull up the calculator, back to stat, edit, clear both of our lists. Okay, and we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the first list. All right, let's try to fix that. Okay, now over to L2. So then we have 20, 30, 60, 60, 70, 90, 100, 130, 130, 150. Okay, so quick check. We have the same number of entries in each list, and looks like we typed everything in correctly. So back to stat, over to calc, choice 4, so we don't have to scroll down. L1, L2 is there. Go to calculate, hit enter. And there we have our linear regression. So we'll pull that into the notes. Okay, so our equation with everything rounded to the nearest integer is y equals 14x plus 5. Okay, so main idea from this video was scatter plots and the line of best fit. And for the line of best fit, we estimated some by hand, and then we followed that up by finding the actual equation with the calculator. Once we had that linear regression equation, we used it to answer some further questions, whether make a prediction, figure out the difference between the prediction and the actual, or to interpret the slope or the y-intercept. But the most important thing is being comfortable using your calculator. And the only way that's going to happen is if you try a few more of these examples. So that's where I leave you off with this video. Go and try a few on your own. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.